what if we have only even-powered sines and cosines? We looked at something we can do with odd-powered sines or cosines in integral. What if we just have even-powered sines and cosines? Well, it sort of is a little more complicated because you have to use, instead of using the Pythagorean identity, you have to use the double angle cosine identity, and actually an altered form of the double angle cosine identity. And the ones that I use are here, which also reminds me, on that formula sheet, these trig identities are listed. That will be on the test. So when you're making your note card, you don't have to include those, because those will be included on the formula sheet provided in the test. But let's see how this works. And we'll just start with the most basic, I guess, even-powered sine. And that is the integral of sine squared x dx. Yeah, so we don't have an odd power to play our little game with as we did previously. So that's why we have to go with this double angle, because if we did the Pythagorean identity, that would just get us right back to having a squared, well, it'd be a squared cosine there, so just kind of a vicious circle. So anyway, yeah, so we're going to go with this double angle identity. Sine squared is 1/2 minus 1/2 cosine of 2x. So sine squared is 1/2 minus 1/2 cosine 2x. Because what that eliminates is that power of sine being squared. Now we just have regular cosine, not cosine squared, it's just cosine of 2x. And so with a little bit of, well, this first part, kind of think of it as two parts here. We're good to go because it's just 1/2, and we know the antiderivative of that is 1/2 x. Now back here, yeah, it's a little, I call them a little simple substitution. Just let u be the 2x, and then du is 2dx, so du over 2 would be my replacement for dx. So I have cosine of u and then du over 2x. D over 2 is my dx. Yeah, so that's just, well, it's 1/4 now of 1/2 x minus, well, 1/4, right? Because you got 1/2 and basically a half over there. But, yeah, we've got cosine of u, and that's just a simple antiderivative. It's sine of u. And then plus c, since it's indefinite. So we have 1/2 x minus 1/4 sine of 2x. Just replace our u by the 2x. Okay. So that kind of gives you an idea how this all works. All right. Well, what they'll throw at us then, let's do a cosine squared, but so it's the integral of cosine squared 4y dy. Okay, well, we've got the cosine squared, so we only have an even power, so we have to use that double angle. We're going to use cosine squared x equals 1/2 plus 1/2 cosine 2x. It's basically the same as the sine, except the replacement for sine squared, except it's a plus between. It's not that hard to remember, but like I said, it's on the sheet. Check it, but anyway, the other little quirk here on this one is instead of cosine squared x, I've got cosine squared 4y, and so I have to make adjustment for that, but it's pretty simple. Instead of x, I've got 4y here, and so if x is 4y, won't that be 2 times 4? That's going to be 8y. So that's really what it amounts to there. We'll have the integral of 1/2 plus 1/2 cosine. So the x is 4y here, so it's 2 times 4y, so it'd be 8y. okay? But again, we're back to the same drill. The first part is just 1/2 dy, and then the integral of that, and then 1/2 cosine of 8y dy. Just kind of do those two separately because this is just simple antiderivative 1/2 y. And this is just a simple substitution. Not quite as simple as the first one, but it is a simple substitution. Du then would be 8 dy, derivative of 8y is 8, so you're just going to du over 8. We'll replace your dy. So I have 1/2 cosine of u now. Du over 8 is my dy. So yeah, I've got that one set up where I can integrate it, antiderivative. Now we've got 1/8, and over here 1/2, and then over here we got 1/8, so it's 1/16. Antiderivative cosine, so again, it's nice, it's the sine. Then just replace your u with what it's equivalent to, which in this case we call u what? 8y. Okay? All right. Well, what if we have a larger power of a sine or a cosine, and it's even powered? So let's say we got the integral of sine to the 4th x dx. Well, we don't have a trig identity, or I don't know it right offhand anyway, for sine to the 4th. And so again, what we have to do, since it's an even power, we have to change that to be a double angle, which the two double angles we know about are sine squared and cosine squared. So we're going to change that to be sine squared squared again. And now we do know how to do something with sine squared. It's double angle. Since it's an even power, I'm going to have to use a double angle. It's 1/2 minus 1/2 cosine 2x. But then I got to square that. And so yes, we do have to square that out. 1/2 minus 1/2 cosine 2x twice. Let's see, what is that? 1/4 minus, it'll be another 4th cosine 2x, and then minus 1/2, no, it'll be another minus 1/4 cosine 2x, and then we'll have a plus 1/4 cosine squared 2x. Okay, yeah, it's kind of turned out to be a longer process here. Of course, these two you can combine, and then we're going to separate them. So if we combine those, minus 1/4 minus 1/4 is minus 2/4, so it's minus 1/2 cosine 2x here. But again, what I'm going to think of is the integral of this, integral of this, integral of this, because they're all going to be different. Turns out here, what I have to do, just show you. All right, so 1/4, let's just separate these. So do the 1/4 integral, and then minus the integral of this 1/2 cosine 2x dx. And then think about this one separately, because what do we got? We got another cosine squared. We got another even powered of the cosine, and that's just not a nice simple antiderivative. These are pretty simple. That one's just direct antiderivative. This is a little u substitution. But again, on this one, I'm going to have to do a little work on. I'll go over there. But let me go ahead and do, let's see, so this is u equals 2x, so du would be 2 times dx, so d over 2 is my dx. So this will be 1/4 x minus the integral of a half cosine of u, and then d over 2, so that's going to give me a fourth. Now this one, again, like I said, it's an even-powered cosine, so you got to do the same thing again. Change that to the double angle, change it to use the double angle identity for cosine squared. And in this case, it's not cosine squared x, it's cosine squared 2x. So, like we're going to use this one, but again, the x is 2x instead of just plain old x. And so this is going to be 2 times x, but x is 2x, so that's going to be 4x right here. We're not do the double angle, so it's going to be the integral of 1/4 times a half plus a half cosine of 2x, but the x here is 2x. Kind of confusing. The x is 2x, so that'll be a cosine of 4x. 2 times 2x. Okay. With me there? Question or concern? So let's finish this one off over here. We do have the 1/4 x. Got that part done. Now we can do this integral. It's 1/4 minus a fourth. And then we got cosine of u. Integral, antiderivative cosine of u is sine of u. But the u is 2x, so it'll be 1/4 sine of 2x. So the first two parts are done. A little work on this one yet to do. What do we got? Well, distribute. I'll go ahead and distribute the 1/4 just to make it fairly clear. So it'll be 1/8 plus 1/8 cosine of 4x x. Well, again, we've got just a regular antiderivative. That's just going to be 1/8 x, and then we're going to have this integral 1/8 cosine of 4x dx. So let me just rewrite that, because how are we going to do that? Another little u substitution. U equals 4x, and so du is 4 dx, so d over 4 is my dx. So I'll have 1/4 x minus 1/4 sine of 2x. Oh, let's go ahead and combine. Notice I've got a 1/4 x and a 1/8 x. Those can be combined. That'd be 2x, so 3/8 x minus 1/4 sine of 2x plus, now with that u substitution, we have 1/8 cosine of u and then du over 4. So I have 3/8 x minus 1/4 sine of 2x plus 1/32. 1/8 times 1/4, it's 4 there. And the antiderivative cosine is sine. But in this case, u was, so then we have to write again. U is 4x, so it'll be sine of 4x plus c. How's that?